Welcome to the lesson on the graphical method of solution. At the end of this lesson, you will be able to define the general form of a pair of linear equations in two variables and solve the equations graphically. You will also be able to state the conditions for a pair of linear equations in two variables to have solutions. In everyday life, you will find many things that share a one-to-one relationship with each other. For example, the harder a ball is kicked, the further it will go. Other examples include the quantity and cost of things. 5 balls will cost more than 2 balls. The age and the height. As a baby grows, her height increases. The altitude and the temperature. As you go higher, the temperature decreases. Such relationships are linear in nature and can be expressed mathematically as a pair of equations in two variables. In this lesson, we'll discuss how a pair of linear equations in two variables can be represented and solved graphically. Let's see how. Let's begin by defining the general form of a pair of linear equations in two variables. Consider an example. Mekong wants to know the new taxi tariff. A taxi tariff plan has two components: the fixed minimum fare and the variable fare that is based on the distance covered in kilometers. For a distance of 10 kilometers, he has paid a fare of 115 rupees. And for a distance of 15 kilometers, he has paid a fare of 165 rupees. Let's assume that the fixed minimum fare is X rupees and the variable fare is Y rupees. Here X and Y represent the ordered pair. Based on the given data, the first equation is X plus 10Y is equal to 115. And the second equation is X plus 15Y is equal to 165. These two equations can also be written as follows. Based on these equations, we can write the general form of a pair of linear equations in two variables as a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1 and c2 are all real numbers, and a1 square plus b1 square is not equal to 0, and a2 square plus b2 square is not equal to 0. Now, can we represent this pair graphically? Recall that a linear equation in two variables, when plotted on a graph, defines a line. So this means when a pair of linear equations is plotted, two lines are defined. Now, we know that two lines in a plane can intersect each other, be parallel to each other, or coincide with each other. Do these conditions apply to the graphical representation of a pair of linear equations in two variables? Let's plot this pair of equations to understand this. In order to plot the linear equations in two variables, we will have to find at least two ordered pairs for each of the linear equations. Let's consider equation 1. Next, we'll regroup the equation such that y is the subject, or y is on the left-hand side of the equation. Let's call this equation 3. Now, by taking values for x and substituting them in equation 3, we can obtain the corresponding values for y. In this case, we're taking the values of x as -5 and 5. You must be wondering why we have chosen these values. Adding and subtracting 5 will make the numerator divisible by the denominator. So, you will have to do a little bit of analysis before deciding the values you want to substitute. let's substitute -5 for x in the equation and solve it. The value obtained for y is 12. So the first ordered pair is -5, 12. Next, we'll substitute 5 for x and solve the equation. The value obtained for y is 11. Hence, the second ordered pair is 5, 11. The two ordered pairs for equation 1 are -5, 12 and 5, 11. Similarly, the second equation can be rearranged such that y is the subject. This is equation 4. Here the values for x are taken as -15 and 15. Substituting these values for x in the equation and solving it, we get the values of y as 12 and 10 respectively. Therefore, the two ordered pairs for the second equation are -15, 12 and 15, 10. Now, let's plot the ordered pairs for the first equation. We'll get a straight line. Similarly, on plotting the ordered pairs for the second, we get another straight line. As you can see, the two lines intersect each other at 15, 10. This is the solution of the two equations. It implies x is equal to 15 and y is equal to 10. Thus, the fixed component of the fare is 15 rupees and the variable component is 10 rupees. As discussed, when any pair of linear equations in two variables is plotted, two straight lines are obtained. These lines may either intersect each other or be coincident with each other. These lines can also be parallel to each other. Each of these conditions will determine the solution of the equations. Let us look at the first condition where the two lines are intersecting each other. This is possible only if a1 divided by a2 is not equal to b1 divided by b2. Then the pair of linear equations will have a unique solution. Consider the pair of linear equations given here. Here a1 is equal to 2, b1 is equal to 4, a2 is equal to 1, and b2 is equal to -3. On substituting these values in the condition, we get 2 upon 1 is not equal to 4 upon -3. Here the pair of linear equations will have a unique solution. This means that the lines representing these equations intersect only at one point. Next, let's consider the second case where the lines coincide with each other. This condition is possible only if a1 upon a2, b1 upon b2, and c1 upon c2 are equal. In this case, the pair of linear equations will have infinite solutions. Consider the pair of linear equations given here. On substituting the values of a1, a2, b1, b2, c1, c2 in the condition, you get 1 upon 2 is equal to 1 upon 2, which is also equal to 1 upon 2. This pair of linear equations have infinite solutions. A pair of linear equations which has a unique or infinite solutions are said to be consistent pair of linear equations. See, the lines represented by the linear equations are coincident here. A pair of linear equations, when plotted, may define lines that neither intersect nor coincide. These lines are parallel to each other. Such a situation is possible only if a1 upon a2 is equal to b1 upon b2, which is not equal to c1 upon c2. Here the pair of linear equations has no solution. Such a pair of linear equations is said to be inconsistent. Let's look at an example of an inconsistent pair of linear equations. On substituting the values of a1, a2, b1, b2, c1 and c2, you get 1 upon 2 is equal to 1 upon 2, which is not equal to minus 6 upon minus 5. As you can see, these lines are not intersecting. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. Two linear equations in the same two variables are called a pair of linear equations in two variables. The most general form of a pair of linear equations is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1, c2 are real numbers, such that a1 square plus b1 square is not equal to 0, a2 square plus b2 square is not equal to 0. The graph of a pair of linear equations in two variables is represented by two lines. If the lines intersect at a point, then that point gives the unique solution of the two equations. In this case, the pair of equations is consistent. If the lines coincide, then there are infinitely many solutions, as each point on the line is a solution. In this case, the pair of equations is consistent. If the lines are parallel, then the pair of equations has no solution. In this case, the pair of equations is inconsistent.